Hey guys, welcome to day 39 of Codeforces every day until GM. Jeez, it's getting hard to keep track of what day it is. Today's gonna be a short little episode just cause I have some homework to do before midnight. I thought it was due tomorrow, but miscalculation, I've been working on homework like pretty much all day. Had a test earlier today. I think I did okay at best, but yeah, just have to knock out the daily video for y'all, so I'm doing this first before I forget. I just jump straight into it, boys and girls. Good segue. 1100 rated, greedy problem. They're in boys and girls studying in class. Oh, I hate studying. They should stand in line so that boys and girls alternate as much as possible. Okay. Cupid. Let's assume that the positions in the line are indexed from left to right by numbers 1 to n plus m. The number of integers such I is such that positions with indexes I plus 1 contain children of different genders. Must be as large as possible. Help the children and tell them how to form a line. The single line of input contains two integers, n m, separated by a space. Print a line of n plus m characters. Print on the ith position of the character b. If the ith position of your arrangement should have a boy and girl. Oh, wait. Huh? Okay. Okay, so if we take an nm, it was map int input. And then basically what we want to do is alternate as much as possible. So we do a counter, right? And then we check which one's greater. And then that one starts first. This doesn't seem too hard. From collections import counter. And then in counter. Counter in lowercase equals counter in counter m equals counter m. And then if len or if wait, why do I need a counter? It tells me the number. So okay, I don't need a counter. I don't know what I was thinking. If n is greater than m, if boys is greater than girls, we need to do some calculations. Let's see. So we can repeat twice. We can repeat 3 times. So the lesser number is okay. Equals min in m. And then equals max in m. The remainder is the max in m minus repeat count. So now we check if n is greater than m, we set to repeat equal to bg, else to repeat equals gb, and then we print to repeat times repeat count plus 2 equals b, and 2 iterate equals g, plus 2 iterate times remainder. I guess I should have double checked for edge cases, but we got a runtime error, which is interesting because that's not what I expected to get. Why did I get a runtime error? This runs fine. Input is 3.3. Huh? Am I tripping? Uh, where's my submission? I don't really understand. What in the world could be causing this? Yes, I understand. I've submitted the same code before. But I got a runtime error. For 3.3. The 3.3 passes. Runtime error just means something's wrong, right? Something crashes. A program error that occurs during execution, causing the software to crash. What could be causing this to crash? It doesn't crash when I run it. It works on my system. You can try submitting in Python, I guess. Instead of PyPy. No? I don't get it. Misread the question? I mean, if I did, it would give me wrong answer, right? I have never ran into this before. In boys and girls studying, they should stand in a line so that boys and girls alternate as much as possible. Let's assume that positions are indexed left to right from 1 to NM. Help the children and tell them how to form a line. I don't understand at all. The problem requires input output via files. What the? Wait. Has this always been a thing? No. So, you want me to means you have to take in input from input file and output. Why? Why is this a thing? Okay. I mean, yeah, I guess I can do that. How do we do that? It's read, write, blah blah blah. We do. I don't remember how to do this. It's like we can file equals open inputs.txt. As read. And then here we do file dot read line dot split, and then do out equals dot txt as write w. Yeah, that's not what I meant to do. Do this. Then like this. Wait. Yeah. And then output. Does this work? I need to search up how dot write works. It should work. If this works, like this is really dumb. Runtime error. Why? Hmm. Hmm. Oh, I guess. Here's something. Does this change anything? Oh, well, dumbass, like freaking inputs. Like, why do you want files? Nothing. Your other problems don't want that. Okay, well, one problem down. Try to do two more, yeah? 1300. Oh boy. This is gonna take me a little bit of time, as all 1300s do. I see math already. Let's denote dn as the number of divisors of a possible integer n. You're given three integers a, b, c. Your task is to calculate the following sum. Find the sum modulo this. First line contains three space-separated integers a, b, c. Print the integer, the required sum modulo. What the hell is this question? Denote dn as the number of divisors of a possible n. You're given three integers a, b, c. Calculate the following sum modulo. The task is to calculate the following sum. Find the sum modulo. This 2 to the 30, which I learned today to be terabytes, right? So what we can do D is ijk. D1 equals 1. D2 is 2, D3, or D2, 2, D4 is 3, D8 is 4. What is D? D is the number of divisors? So 8 has 8, 1, 2. 4? Yeah. Okay. We add all the divisors. Implementation number theory problem. So it's basically saying how many times does D blank come up? D1 comes up one time. D2. What is IJK? We go from like 1 to 8. Okay. So what's our input? It's this, except ABC. And then this is input.split. So we take in ABC. Mm. A, B, C are bounded between 1 and 100, so our largest possible number is 1 mil. Can we just brute force this? 1 mil max. So mod. So we have mod equals this. And at the end we get, we're printing something like sum mod, right? Now, can we just compute all the divisors? Also, how do we try every number? Like, is there a pattern to this? 2, 2, 2, 4, 4, 4, 8. Okay, I need a whiteboard. So, is there ever like, let's try 3, 3, 3. It's 1, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 2, 2, 1, 1, 2, 2, 2, 1, 2, 2, 2, 2, 3, 1, 1, 3, 1, 1, 3, 1, 1, 1, 3, 3, 3, 1, 3, 3, 1, 3, 1, 3, 3, 3, 3, 3. Right, so we have 1. These are the same. These are the same. 1. These are the same. These are the same. 1. So there's this pattern until repeating. It's like 3, 1. It's 3, 1, 3, 3, 1. So we only have to worry about one orientation of the 3 numbers, but just multiply it by 3. Hmm. how do you do this? So for 222, it's 1. Okay, but it's the number of divisors of the multiple. Not just the multiple. So we had to compute divisors until A times B times C before anything, right? Like, gotta do. And steal this code here. My divisor calculator. Except we replace periods with divisor. And C. Okay. Now, how do we do this? If it's 3 of the same number, it counts once. Okay, so we have 3 cases. Case 1, A equals B equals C. Total plus equals D. Wait, now I'm confused. This computes the divisors, not the divisor count. Hmm. What we need to do instead of we need it. Okay, divisors, indexes, values, right? Our indexes need to hold like D0, D1. These are our indexes. Should pull out the total number of divisors. Your value should be a count, not a divisor. So this doesn't work, actually. So our divisors would be 0 times n plus 1, because we don't use 0. And then we iterate through this. Oh yeah, we can't use this at all, I don't think. For I in range 1 n plus 1. This is kind of like a prefix sum. Because you take the number of divisors before it and you just add 1. Because it's like 8. Wait. 2, 4, 2, 2. 2, 1. So we have D1 is 1, D2 is 2, D3, D4 is 1, 2, 3, D5, D6, D7, D8 is 1, 2, 3, 4. So D7 is 2, D5 is 2, D3 is 3, D6 is 6, 3, 2, 1, 4. Okay, and here's an interesting thing. We're never going to land on these prime numbers. That's not true. They can be multiples. So let me think. For I in range from, we're looking from 1 to 9. Mm. So, okay, so every element in divisor is at least one, right? Because they can divide, one can divide everything. Hmm. So what we need to do is loop through and then check for each multiple. So that's what I is. I is the multiple, where n plus 1 is the max multiple. So it's going to be 8 because it goes from 1 to 9 maps. Like it checks. Okay, it's like this. And then if this is the multiple, we need an increment. We need like j. For j in range, we start at I, and then we end at n plus 1, and then we increment by I. So if I is 1, then we check 1, 2, 3, 4, 5, 6. I is 2, we check 2, 4, 6, 8, and we add 1 to each of those. And then if it's 3, 3, 6, 9. So we do divisor or j plus equals 1. And then that should handle the divisor part. Now for the total part. 1, 3, 3, 1. We only care about incrementing A, right? Because A kind of follows this modulus pattern. Well, until we hit like the minimum number. Let me think. Oh no, wait, it's not 1, 3, 3, 1. It's 1, 3, 2, 1. It's just 3, 2, 1, 3, 2, 1, 3, 2, 1. So the bottleneck for this like 3, 2, 1 repeating pattern, like 1, 3, 2, 1, 3, 2, 1, is just the minimal number. In this case, it lands on 2 perfectly, but if it's like this, it'll land on 5. So it's 1, 3, 2, 1, 3, 2, 1. Hold on, let me find some room. And then it will be, this is 1 repeating, 2 repeating, 3 repeating, 4 repeating, 5 repeating. I don't think this really works. Because then, for the leftover work, we had to do it manually anyway. For this, we still have to check each divisor. So why not just, like, brute force, like, for A, for B, for C, and then 1 pass it. Not 1 pass it, but, like... I don't think this makes it faster at all, actually. I think we can just, for I in range 1A plus 1, for J in range 1B plus 1, and then for in range 1C plus 1. What's the time complexity for this? I get 2 seconds. Definitely gonna bookmark this question. And then we need a track. Total plus equals divisors I times j times k. We can technically save calculations here. We can do like ij equals I times j, and then replace this with ij. Something like this. It works. The question is it fast enough? We can try. It seems to be working. Great. I kind of just brute forced it though. Was there really no cool tech for this? We can make a table of size ABC to store every number's D value. That's this, right? And we can just brute force through every tripe to calculate the answer. Triple? What is this trying to say? Tripe? What is a tripe? Edible lining of an animal's stomach. I think they just misspelled triple. Well, this was kind of a boring question. I mean, everybody and their mother knows, like, how to brute force this. But it's, like, not fun when it's just brute force. I spent half the time thinking of a novel idea. Kind of disappointing, but... Okay, we'll call it here today. It's been 54 minutes. If you like this video, make sure to like and subscribe, and I'll see y'all guys tomorrow. Bye.